Hello everyone and welcome to Warwick Data Science Society's course, Python for Data Science. I'm Tim, the current president of the Data Science Society and the author of this course. In the next 5 sessions, we're going to have a look at the use of Python for data science and scientific computing, learning about the industry standard packages of pandas, numpy, scikit-learn and matplotlib, and hopefully giving you the tools to go out and solve whatever database problems that you have. So before we start, we're going to have a look at how we can set up Python on your own computer. And if you took our beginner's Python course, you might be asking, well, why do we need to do this? Can't we just use Google Colab like we did for that? And it's true, Google Colab is a very easy to use, easy to set up tool, but it's not an industry standard. If you want a job in data science or really anything data or coding related, you will be expected to use Python on your own computer and know how to set that up and work with it. And so that's what this session is about, showing you how to get that sort of stuff set up. And there's the added bonus that will show you how to set up a portfolio on GitHub with all the work that you do for this course. So this is only going to be a very brief introduction to how we use all the tools for running Python on our computer and for building this sort of portfolio. If you want a more comprehensive understanding, we're running a course, Reproducible Science, at the end of this term. So if you're on the first iteration of this course, wait for then. If you're on a latter iteration, it's out already. Have a look on our YouTube to find the playlist. It also might be a bit difficult to get these things set up, but it's worth it. Once you've done it once, it's done forever. If you have any difficulty, you can either reach out to whoever is running the course at the current time, or if you're teaching yourself independently, feel free to reach out to me, and the link to my LinkedIn will be in the description of this video. So with that, let's get started. Okay, so we're going to start by looking at a tool called Git, and a website called GitHub, which works very well with it. So Git is what is known as a version control system. This is a piece of software used for keeping track of the changes we make to certain files. So the reason we would want to have this is that we can keep track of where our files are at various points. If we make a change to our code and we break something, we can always roll back to a previous version. Also, more advanced uses make it very powerful for collaboration and for sharing code with other people. And then GitHub is a site where we can store a copy of our files. So we have them on our local computer, and then we back them up to GitHub, which is used for kind of a central collaboration space or a space to kind of show off the work that we're doing in a form of portfolio. So we're going to start by getting Git installed. I'm not going to go through this because it's going to be different for all different operating systems, but I'll link to the download site here, and the instructions are all given here. So if you're on Mac, Windows, or Linux, you can follow these links and it will explain to you how to get that set up. You'll also need to create a GitHub account. It's as simple as just signing up to any website, and you do that at github.com. And once you have a website, we can create a new repository. Think of a repository as a project or a location to put all code related to a certain thing. And we'll create one for this course, and you can put all of your code on there, and then you can share that with people if you want to kind of show them what you did in this course. So once we're on GitHub, if we go to the top right and make sure we go to our profile, we'll be greeted with a page like this. Actually, this was the wrong place. We wanted to go to your repositories. And this will be empty at first if you haven't created anything. And we're going to create a new repository, so a new place to put our code for this course. And we're going to do that by clicking New. We're going to give this a name. Let's call it Python for Data Science. And you could give it a little description if you wanted. You can have this public, that means that anyone can see it, or private, meaning only you can. I'm going to have this one as private because I already have my own version of this, but you are more likely going to want it public so you can share with people what you're doing on this course. No need to take these things at the bottom. We'll actually no. Let's add a git ignore for Python. If I can spell that correctly. So what this means, a git ignore is a list of files that GitHub shouldn't pay attention to. And these are typically kind of temporary files or kind of cache files which kind of store bits of information for use on your computer, but you don't want to be sharing them with the world because it's kind of redundant for anybody else. So we just add the Python one, it's pre-done for us, we don't have to worry about that. So from there we can create the repository, and we'll be greeted with a repository just with this git ignore file and nothing else. So now we want to get this onto our computer. So the idea is with GitHub is like the central authority where the code sits, and then multiple users can create a copy on their own computer that links to this main one, and that allows you to kind of collaborate between users. But in our case, we're just going to have a single connection from our computer to GitHub. And so to do this, we can go into this code button here, and there's two options, HTTPS or SSH. If you're using Windows or Mac, HTTPS is probably the one for you, but Linux, you might want to use SSH and set up an SSH key. That's a bit more of an advanced use case. I'm going to use this because I'm on Linux, but you're most likely going to want to use HTTPS. But the actual process you follow will be the same. So we're going to copy the link here, and then we're going to open our file explorer. So just the place where we have all our documents stored. And we're going to find a place where we want to have this repository, so where we want to store our code. I have this folder in my documents called teaching. I'm going to put it in here. So once we have Git installed, we can use that to copy this repository. So kind of Git is the language for communicating between ourselves and GitHub. And so the first thing we're going to want to do is to copy this repository from GitHub to our own computer. And we can do this by, if we right-click somewhere in here. If you're on Linux or Mac, you can open a terminal. And if you're on Windows, you can open a piece of software called Git Bash, which is installed when you install Git. So I'm going to open here. And the command we're going to run is git, so that's the language we're using. The command is clone, so make a copy. And then we just copy in that URL, or in this case, it was an SSH address, for the repository, the one that we copied from GitHub. We press run, and that's going to create a copy of our of the repository here. So I can go inside of here. I can then open either Git Bash or the terminal on Linux and Mac again here. So this is where we're going to put all of our files for the teaching course. So for example, if I go to the teaching course, education, go down to this course, and we should have session 1 here. There we do, yeah. So I'm going to get the questions for session 1. That's going to open this text file here. It's going to look like this for you. I've got a plugin to process it. We can right-click, save that, and we can go put that in this folder. So in teaching, Python for data science, and I'm going to save this as session 1 teaching. Okay, so we now have this file sitting here. And I'm going to briefly show you how to use Git. So currently, we have this file on our computer, so we can see it's here. But if we go to GitHub and refresh here, it's not sitting on this online version. And the reason for this is that changes are not made automatically. You have to manually submit these changes and send them across to GitHub. Now we're going to go through this very briefly. Again, as I mentioned earlier, we are running a reproducible science course to give more detail on kind of what Git does and kind of why you should be using it. But here we're just going to introduce the basic steps. So the first command we want to look at, and this terminal, I had this by going into the folder, right-clicking and opening my terminal, or opening Git Bash on Windows. And then the command I can use to kind of see what current state we're in is git space and then status. So it's saying we have one file that isn't being tracked, so Git isn't aware of this file. Okay, so let's make Git aware of the file. We do this by using git add, and then the file that we want to add. And we can use tab completion here. If we press tab, it will auto-complete it if there's only one option remaining, or it will go up to where the two options diverge. So we can add this to Git. And now Git is aware of this change. I can have a look at the status now, and it says we have one file being tracked, but it's not committed yet. So committing is kind of saying we want to make this change and labeling what that change was. So I can do git commit, and then we follow this with -m for message, and then in quotes kind of a label saying what we did. And so in this case, I added session 1 questions. And we tend to write it in the imperative voice, like a command. Add session 1 questions. I run this, and now Git has committed those changes, and it's kind of given them a label. You might make a mistake and run git commit without the -m. That's going to open up an editor called Vim. If you want to get out of that, you have to run :q exclamation mark. Bit of a weird command, but that's how you get out of that if you forget the M. Or the -M, sorry. So let's look at git status again. We now have that the changes are committed, but we're one commit ahead of origin master. So origin refers to GitHub. You think of origin as like the central point, and GitHub is the central point for all of our code. And master just refers to the branch we're on. This might be called main for you, which is kind of more kind of modern repos on repositories on GitHub have been renamed to main because it's a bit more politically correct. And so now we just have to send that change across to GitHub, and we do that using git push. So take those changes and push them out to GitHub. We run this, and it might ask you for your username and password. You can just type those in. And once we've done that, we have a look back at GitHub, refresh here. We see that the files are here. I can have a look at this, and currently it's completely empty. If it will even load up, these blank boxes here where we would put our answers. But as we kind of go through the course, once we see how to actually edit these files, once you've made your changes, you can use git add to add the file again, or add the changes made to it. Git commit saying what changes you made. You know, you finished question sheet 1, you finished this question, made a change to this question, and then push those across to GitHub. And so in the end, we should have a repository full of 5 teaching sessions and 5 project sessions that you can show off to people. Okay, so we'll now look at how we can actually edit this code and run Python on our computer. So we're now going to have a look at how we can install Python on our computer. And this is likely the most complicated bit of setup from this video, but once it's done, you have Python installed, you don't have to worry about it again. And we're going to do this using a tool called Conda. There are various ways you can install Python. You can do it directly from the Python website, or using a tool called Anaconda, or you could use your system's Python if you're on Mac, Linux, and maybe Windows has system Python, I'm not sure. But all those methods have a lot of flaws. I'm not going to get into them now. Conda, for me personally, and I think a lot of data scientists agree with this, is the perfect balance between functionality without being bloated. And what Conda is, it's kind of it's a minimal installation of this tool called Conda, which is used for kind of managing Python environments. And what I mean by that is that Python is a very open source language with lots of packages that you can install. And Conda is a tool for installing these packages. But more importantly, it installs them in a dependency-aware way. So it knows that if I have this this package, it might need this other package and a certain version of it. And it keeps track of all of those dependencies, making sure that your environment is compatible. And other Python tools do not do this. It's your responsibility to sort out, well, if I have version 2 of this, I need version 1.3 of this, and it becomes a nightmare. Conda does that all for you. And Conda is the smallest installation of Conda. Conda can also be used for these things called virtual environments. And these are ways of kind of partitioning your kind of computer or your Python environment into individual sets of packages for each project. So for your Python for Data Science project, you might have a certain set of packages, and for a different project, you'll have a different set of packages, and those won't interfere with each other. They're kind of isolated bubbles of packages. So to install Conda, you can go to this site, will be linked in the description. There are installers for Windows, for Mac, and Linux. You likely want the 64-bit version, and you definitely want Python 3.8. Python 2.7 is retired now. So figure out what bit version your computer is. It's almost certainly 64-bit if you're not sure, and then download that and install it. If you get the option to add it to your path, do this. This is the correct thing to do. If you don't see that option, or if things later on in this video don't work for you, then have a search for how you can add Conda to your path on whatever operating system you have. There should be instructions for that on the internet, or you can get in touch with course coordinators or me if you're self-teaching. Okay, so once we have that installed, let's kind of go into our folder where we have our Python for Data Science. You'll see a jump cut there because I messed up the installation the first time. So I guess it goes to show, even when you do have experience with this stuff, it still can be complicated. So don't worry if you find this difficult, do reach out for help. So we're now going to set up Python using Conda in our Python for Data Science folder. I'm going to do this by right-clicking and opening a terminal if we're on Mac or Linux, or if we're on Windows, we have to right-click while holding Shift, and then an option for Open PowerShell will appear. Either way, we'll get some sort of terminal like this. And we're going to use commands using the tool Conda. If when you do these commands, you get something like Conda not found, couldn't find binary Conda, it's because you haven't added Conda to your path. So have a search for that on the web or ask for help. So we're going to create a new environment for Python for data science. We're currently sitting in our base environment. This might not be displayed for you, but yeah, we're currently sitting in our kind of general system-wide environment, but we want a specific one for this course. And so we can create this using the command conda create and -n, that stands for name, and we give it a name. And so you could call this anything, but I would strongly advise to give it the same name that I've used. And in that way, you can open up these notebooks that I provided, and it will just work straight off. You won't have to select a different environment because yours is named something different. And I named it pyds, for like Python Data Science. And we follow this up with what we want to install in this environment. I'm going to want Python, preferably version 3.8, so Python equals 3.8. We're going to need a tool called ipykernel and a tool called Jupyter, and then Jupyter Lab, one word. So 4 things we need installed: Python version 3.8, ipykernel, Jupyter, and Jupyter Lab. So let's just run through quickly what these are. Python, we know what Python is. Jupyter is basically the local version of Google Colab, or more specifically, Google Colab is based on Jupyter. And so this will allow us to work in an environment similar to Google Colab, but on our own computer. And Jupyter Lab is a more modern version of this that has some kind of nice features like drag and drop. And ipykernel is the tool we use to take this environment we've created and run it inside of Jupyter. So we need to then run this. I press enter. I've done this already, so I'm not going to press enter. Don't want to install it twice. And once you've done that, it will do this thing called solving the environment. And that means that it's trying to figure out what combination of versions of packages are compatible together. Once it's figured out a solution, it will give you a prompt saying, do you want to go ahead? Y/n, yes/no. Type in Y and press enter, and that will install all of the packages. So once you've done that, you can then activate the environment. So we're currently in our base one. If you want to use our Python data science environment, we have to activate it. And we do that with conda activate and then the name of the environment. So we called it pyds. If you called it something different, you use a different name. We run that. You can now see I'm inside of pyds. So I'm in the same location. I'm still in this data science folder, but the environment I'm using is Python data science. And so currently we've installed kind of the main requirements of Python, Jupyter, and ipykernel. We also need to install the packages we want to use for doing data science. And so we can do this with conda install. The packages we're going to need are NumPy, pandas, scikit-learn, and matplotlib. You're free to install any others, but those are the core ones we're going to need. You can run this, and it's going to solve the environment, trying to figure out what packages are compatible with each other. And once it comes up with a solution, we can then prove that by pressing yes, and it will install those. So you can see it's going to install these. Well, I had these installed already, so there's less things that need to be happening. You can just press yes to confirm that, and that will actually go and do it. So the final thing we need to do before, actually let's keep this small, before we actually use Jupyter to do some coding, is to install this environment inside of Jupyter. And the command we do for this, while inside of our environment, is python-m ipykernel, make sure you get the spelling of kernel right, --user, --name, and the name we're going to give it is pyds, and then the display name, so --display-name is going to be Python for data science. And try and get these exactly the same. It'll just make it easier for running these notebooks without having to select something different. But I'll show you, if you did name it something different, what you'd have to do later on. So you'd run this by pressing enter. I won't run it because I've done this already. Don't want to install it twice. And at this point, we're ready to use Jupyter. So the command to launch Jupyter is Jupyter Lab. And we do this from inside of our environment. So we run Jupyter Lab, It didn't like that. Oh, I guess I haven't installed Jupyter Lab. So I will install this here. So I'm going to install that, just approve of that, and now we can run Jupyter Lab. That's going to open our browser, and we're going to get this Explorer here. We're going to want to use this file window on the side here, and open up whichever document we want to edit. So in this case, session 1. We open this up and we see we got something really similar to Google Colab. So we have all these cells here. We can drag them around if we want. There is a code one here, and we can type in our code. We'll see this more in session 1. And then we can run that using either the play button at the top, there's no play button on the side now, or Control Enter. We get the numbers like in Colab, it's very similar. Now, if you'd named your Python environment differently, then you might get an error saying, hey, we can't find the kernel. And it's going to look something like this. It's going to tell you to select a kernel. And so what you're going to do, you're going to find the one you want to use. And so it's going to be the one you created. So I have one for my base Python, one for TensorFlow. Python for Data Science is the one I want to use for this. So I click that and select it. And now you would be using that for Jupyter. That's how we would use that. We can go through running our code. Once we're done, we can just close the browser, which probably want to save first, but I won't save this time. And then we can go back to our terminal. If we still have Jupyter running, so to stop that, we use Control-C. It's going to say, do you want to shut down Y or N? If we're not fast enough, it's going to start running again. We have 5 seconds to answer. So Control-C to quit, and yes, I do want to quit. Now at this point, we're still inside of our environment. To turn the environment off, we don't have to do this. We could just close the terminal at this point. But if you wanted to kind of go into a different environment to disable this, you use Conda deactivate. And we're back to our base one. So just to run through now what we would do if we wanted to edit this again. We don't have to install the things again. We've done that before. We would open up our terminal or shift right click, open PowerShell. Then we would activate the environment, so Conda activate whatever name we gave it. So pyds was mine. We'd run Jupyter Lab. And yeah, there we go. We have Jupyter Lab open. We can make the changes. Once we're happy with things, we then go back to using Git, as we saw earlier in the video, to send those changes up to GitHub. So lots of new ideas to take in. It's going to be confusing at first. If you try and follow these steps and stick to them, make sure you get all the commands exactly right, you should be okay. If there's any difficulties, you can always reach out to the course coordinators or to myself if you're teaching independently. So hopefully that's working all right, and I look forward to starting the actual teaching content. See you then.